Hello everyone, welcome to Geeks for Geeks. Myself Abhinav Awasthi. I am a DSA mentor at Geeks for Geeks, and today there is a new video of mock DSA interview. Okay, so today we have Nikhil with us. Hi Nikhil, how are
Hi,
you?
sir. Hi, sir. I'm fine.
Okay, so Nikhil, are you ready for this
Yeah,
interview?
I'm quite excited for it.
Okay, great. I too. So can you please tell me something about your projects and stuff which you are doing?
Basically, I have been working on projects in web development. I have been working with technologies like Node.js, React.js, HTML, CSS. Uh, I have built some projects. I have built some projects. One of them is Mappy that uses a live map using. I have implemented that using a leaflet library that is an open source library that allows us to do stuff on the map. Uh,
Okay.
uh, rather, and currently I am working on a chat app using React so that I can learn React in more advanced, like custom hooks. Uh,
Okay.
um, that's it.
Okay, yeah, great. Cool, Nikhil. So, great. So now let's start with our mock DSA interview. So, can you please share your screen with the sheet I have shared?
Yeah. Just wait a minute.
Yeah.
Uh, is it visible, sir?
Yeah. Okay. So, just a reply from all of the viewers. Is this the audio is clear and the sheet is visible? Fine. So that we can start. Great. Okay. So, fine. So let's start with the first problem. Okay. So the problem statement is like that. Uh, that you are given with n numbers, you are given with an array of n numbers, okay,
Okay.
and or basically you are given with the array of n minus 1 numbers, okay,
Okay.
and in that array there are distinct integers which are ranging from 1 to 9,
1 to 9. Okay.
okay. So there are distinct integers that are ranging from 1 to n minus 1 basically. If there are, if the value of n is 9, then they are ranging from 1 to 9, okay.
Sir,
So
I have been not clear with the question statement.
yeah,
Is
yeah.
distinct integers from 1 to 9 or 1 to n minus 1?
Let me just explain that to you. That for example, the size of our array is n minus 1, okay.
Okay.
So in that array there will be integers from 1 to n basically. Getting
Okay.
it?
Now I'm
Fine.
clear with it. Okay.
Yeah. So what you can say is that, and all these integers are distinct. So
Obviously.
obviously if the
Okay.
integers are from 1 to n, and in that array there are only n minus 1 integers, so obviously one integer will be missing. Getting
Okay.
it? For example, the value of n is 5.
Okay.
Okay. And the array is ARR. That array is basically 1, 3, 5, 4. This is the array given to us. So in this array, you can see that 2 is missing.
Okay.
2 is the missing number. So you have to basically tell us that in the array which contains n minus 1 elements, which number is missing.
Okay.
Yeah.
So may I start, sir?
Yeah. You can just
Uh,
first think of the solution. You can write the pseudocode also. You can tell me the, you can just start with the brute force approach, then the another one. Okay, just a minute. Just a minute. Just let me give you the thing. Yeah, now you can go. Great.
so basically, what I will do, uh, sir, um, sir, I have not been allowed to write in this document.
Just refresh it. I have just allowed you.
Yeah. So
Yeah.
basically what I will do, uh, there is one property, there is an first of all, if I talk about the knife solution, so what can I do? In knife solution, I can take a map and I can put all these elements in the map. Uh, so basically, what will our map look like? Map or a set? Basically, I will put it in a set, unordered set.
Okay.
So it
Okay.
will be look like 1, 3, 4, and 5. Uh, then what I will sorry 1, 3. Uh-huh. So then what I will be doing is I will be iterating from 1 till n, and I will be finding that if my set name is st, then I will be doing an operation st dot find that element. Let's suppose 1, then 2. The moment I will find the element is not present in the set, uh,
Okay.
the element is not present in the set, I will return the answer. So basically, the time complexity of this approach would be I will be at worst I will be iterating all the n elements. So time complexity
Yeah.
will be O of n, but
Okay.
and space complexity, since I am using a set, I am using extra space. uh,
Yeah. Exactly.
I have just missed out one thing in set when I will be finding an element in an unordered set is O of one time. So basically, overall time complexity will be O of n only, and a space complexity of O of n.
So
Uh,
what is the time complexity required when you will add elements in the set?
it is O of 1 for unordered set. If I
Okay.
am using an ordered set, it uses a uh, uh, tree, red black tree. So it is log n in that case.
Exactly. Great. Fine. So can
Uh,
you please write the pseudo code for your approach if it's the efficient
uh,
approach?
uh, uh, Sir, I don't got you. Should I write for this approach or for another approach?
Yeah. Tell me the approach. If have you any other approach for less
Yeah,
time complexity
yeah,
or
I have.
less space complexity? Yeah.
Yeah, I have one approach with a constant space. So
Great.
there is one property of XOR operator. This is the XOR operator. It has one property. If any element is XORed with itself, it gives a zero, and a zero when XORed with any number. Let's suppose 4. So it will provide a 4. Means what I am trying to
Great.
say, if 1 is XOR with 1, it will give 0. And if 0 is XORed with any number, it will give 4. So basically what you have given me, an array of numbers. Let's suppose 1, 3, 4 and 5, or 5 and 4. I have indices 0, 1, 2, 3 for these numbers. So what I will do, I will XOR I will XOR ARR of I. I will XOR ARR of I. Just a second. ARR of I with I plus 1. Uh, and store it
Okay.
in result. Sorry, XOR. It should be XOR.
Yeah.
And store it in result, and XOR with result. And initially the result should be 0, because 0 XOR with any number gives that number only. So
Okay.
what will happen when this 0 will come? What will In first iteration what will happen? 1 will XOR with 1, then the next iteration comes. So what will happen? 3 would be XOR to 2, then 4 with XOR to 3, then 5 with XOR to 4.
Great.
So what will happen? 1 with
Hmm.
pair with 1 and give a 0.
Fine.
Uh, then 4 with
Can
XOR
you
with.
please can you please slide it down the seat?
Okay.
Yeah. Yeah.
Then
Great.
4 with XOR with 4 will give a 0. So we are
Fine.
left with 3 and 3. 3 and 3 XOR will give uh, 3 and 3 will give uh, 3 and 3 will give a
Zero.
0. And since
Fine.
we know that it is an array of n minus 1, and we have n numbers in which one is missing, so we have to XOR with that last n also, because uh, we have n minus 1, we have been given with n minus 1 numbers. So to find that nth number should also be XORed na, for one clubbing that is left.
Okay,
So
fine.
5 will XOR with 5, and we will be left with 2, which will be our answer.
Okay,
And
I am getting it. Fine. So can you please add a pseudocode for it? A pseudocode for this particular solution?
yeah, I can write it.
Okay.
Let's suppose our integer array is our array is given. So I will be storing a result, and then I will be running a loop from 0 till n minus 1, or I can store n also in this, so we have not to XOR it at last.
Okay.
Uh, n minus 1 elements, okay. Then result will be equals to result, oh, result will be equals to result XOR with ARR of I, XORed with I plus 1, I plus 1.
Okay.
Okay. So at last, what will be our result? We will just simply return it. It will complete. It will contain our answer.
Okay.
Uh,
Fine. Fine.
so, may I tell the time complexity?
Yeah, time and space complexity.
So as we can see, we are running an loop which is n minus 1 times. So time complexity will be O of n minus 1, which is as good as O of n, and a space complexity of O of 1, as only we are using this result variable.
Okay. Okay. Fine. Great. Okay. Yeah. So this is what I actually want. Okay. That is, there's one more solution which is based on
Yeah,
mathematics.
I know one more solution also. May I tell?
Yeah. Yeah.
Uh,
Please.
I know a solution known as cyclic sort.
Okay. Yeah.
So basically, what I do in this solution is that, as we know, the numbers are from 1 to n. Number
Okay.
are from 1 to n. So we can take an advantage of indices of the array, that we can map. Uh, we can use cyclic sort, which is an in-place algorithm. Basically, it is a technique. So what we do in this technique is, uh, as we have indices from 0 till n, 0, 1, 2, 3, till n minus 1, we will go, as you are saying that we have n minus 1 elements. Okay.
Okay. From one
And
to n minus one.
1 to
From
n
one to
minus
n. Okay.
1 to n minus 1. No, I'm talking about indices.
Indices.
Numbers are from 1 to n, numbers are from 1 to n, and we have
Okay.
indices from 0 to n minus 1.
Okay. Great.
So we can map, let's suppose 0 will be mapped to 1, 1 will be mapped to 2, if it exists. 2 will be mapped to 3 if it exists. 3 will be mapped to 4 if it exists. Uh,
Hmm.
and then n minus 1 will be mapped to n, means each index will be mapped with a number greater than 1 of the index. So the moment we will find that for a particular index we don't have a particular n, so means this index can't be mapped, so that number is missing.
Missing.
uh,
Okay. Means you are saying that you have to just search for the corresponding number for a given index. And if
yeah,
that number is missing, then that is the missing number of that array.
okay,
Okay. Fine. Yeah. So this is one more solution for this, which is a cyclic sort solution. Great. And okay, fine, Nikhil. Uh, that is what I was searching for. That XOR solution. That is the, I think, the
okay,
most efficient one, and the most easy to implement also. And
yeah,
this cycle sort one also is also good. Okay, great. So can you move towards the next problem?
yeah.
Okay, great, great. So okay. So the next problem is that you are given. Okay. So the thing is that you are given with a string. Okay, the
Okay.
string is given to you, and let me just share that problem to you in the screen also. That thing. So for example, the string given to us is A, B, C, B, D, A, C. Okay, is this visible?
Yeah.
And then you are given with some queries. Okay, you are given with some queries on that string which you have to perform. Each query will have an index L and the index R. Okay, so for each query, you have to take a substring from index L to index R. That is clear. You have to take a substring from index L to R.
Okay.
Fine. Now, the next thing, you have to find the number of distinct characters in that particular substring. For
Okay.
example, the case which we are taking is this one.
Yeah.
Okay. In this case, if you will see that, if you will find it that for let's say L is equal to 2 and R is equal to 4. This is a zero bias indexing. Okay. So
Yeah.
this substring will be, this is index number 2 and this is index number 4.
CBD.
CBD. Okay, CBD.
Yeah.
And if I will just focus on the CBD, you will say that there are three distinct characters.
Three distinct
This
characters.
CBD all are distinct. If I will take from 0 to 4, so it will be this one.
The
Okay.
four distinct characters.
Yeah. So here are basically B and B are repeated. So here are four distinct characters.
Okay.
So similarly, you will be given with multiple queries for a given string, and you have to find that what are the distinct number of characters for a particular substring.
Okay.
Okay, fine.
Uh, so basically, sir, can you tell me about the constraints, like what, how many queries you will make, and what will be the size of the string, so that I can. Uh,
Okay. So let's assume that the size of the string is till 10 to the power 5. I'm just writing here
yeah.
that n is between 1 to 10 to the power 5. Okay, and the number of queries are something like 10,000 queries are there.
1,000 queries are there. Okay.
Yeah, 10 to the power 3 queries are there.
So
Let's say.
basically, I have to write a solution in which I can. Sorry, 10 to the power 3 queries are there.
Yeah.
Okay. So, what will be the naive solution which will give obviously the time limit exceeded error would be for every query we just iterate and find we just iterate and put every let's suppose the query is should I write it down
Yeah, sure.
A B C D D A C. So if as you given the case L equals to 2, let me take L equals to 1 and R equals to 5. So it will
Okay.
be string substring 0, 1, 2, 4, 5. B C B D A. It will be B C E D A. B C E and D A. Okay. So basically this is our substring. So what we will do, we will start a loop from L till 5, start a loop from L till R, and we will put
Okay.
everything in a data structure known as set. Uh,
Okay. In a
uh,
set.
in a set. So
Okay.
what set does, it doesn't allow multiple entries. Means B, I will store a B, then a C, then again then when B will come, it will not store it as it is already in the set. Then a D, then a
Okay.
A. And for each query, if I will return the size of the set, uh, so that will be our answer, the number of distinct uh, elements in the set.
Okay.
That will be the distinct element from L to R of the substring. So for every query we will do it, so it will take a hell lot of time.
Okay. Yeah. Means each
Uh,
query will take time complexity of O of n.
yeah, if it is a
Okay.
in worst case, it will take a time complexity of O of n if the size of its string O of 10. It will basically take n into q time, I guess. Yeah,
Okay.
if n is the number of queries and if n is the size of the string and q is the number of
Means
queries.
you are saying that for each query you will just iterate from L to R and then
Yeah,
storing that numbers in a set, and
yeah,
then the size of that set is the number of distinct characters. Na, that
yeah,
is what you are saying.
yeah,
Okay, so that will take, I think, n into q time complexity.
yeah. Time of n
Fine,
into
fine. Okay, yeah, I got it. I got it. So can you please can you just think of a more efficient solution?
uh, okay. Just
Take your time. You can take pen and paper. You can just search of check for it. You can solve it here only.
so one solution which I could think of is pre-computation. Uh,
Okay.
uh, uh, what I will do, uh, 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 sir, should I know that the alphabets are from in lowercase or it can be in uppercase also?
Now all are in lowercase. They all are
Lowercase.
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 Yeah.
So basically,
Yeah.
what I will do, I will instead of map as it takes a high complexity because it involves hashing also. I will take a vector in C++ vector of int v or a simply a array. Basically, a array of 26
Okay.
array of 26. Now, what this 26 is, as we know, our alphabets are from 0 to alphabets are from A to Z, which are 26 in numbers. So, I will map 0 to A, 1 to B, and so on till 25. Okay.
Okay. Fine.
So, what I will do, I will take in C++ a vector of vector a vector v that will be of size n, that is the size of the string, and that will
Okay.
store a vector of int of 26 comma 0.
Okay.
uh, got it.
Okay. It means you are taking a 2D vector, basically a two-dimensional vector,
Two
and
dimensional vector,
with
two
n rows
dimensional.
and 26 columns.
Yeah. So what
Okay.
basically
Fine.
what I am doing, I am iterating from 0 till n. I am iterating from 0 to n, and I am maintaining a vector. I am maintaining a vector. I have taken another vector of size 26. I have taken another vector of size 26. I have taken another vector of size 26. Sorry. Let's name it as vec of 26. And I have started my iteration from this index 0a. So what I will do, as I have found a, I will I will increase its increase its frequency by one. Initially, initially our vector have a to z, but all of them have zero frequency. I will
Okay.
uh, I will increase its frequency as I go. So s of I minus a. So what this minus a will do? This minus a basically this will give us the index. Uh, as we know, our characters are stored in ASCII values. So s of I
Okay.
will give a ASCII value, and we will minus the ASCII value of a, which is 97. So as first character is our a, so 97 minus 97 will give us the index 0. As From that we will get the index of
Yeah,
all the
I got
characters.
it. I got it.
So
Means if we talk about the index of A is 0, and then
yeah,
what will be the index of Z?
Z will be, I guess, 97 plus 122 is Z, I guess, in ASCII characters. So 122 minus 97 will be Z. That is 25.
Yeah, because there are 26 characters. So if 0 is A, so Z will be 25.
So
Yeah, okay. Right.
it's an array of 26 characters. So what I am doing, I am just increasing the frequency. So till here my vector is till here my vector is only uh, till here my vector is only let's suppose huh,
So can you please write this thing? Because it's quite confusing that you are taking two vectors, one is a 2D vector. If
huh,
you
huh.
can write that thing for this particular problem, that this
So
is the
basically
string and this is the value of LNR.
uh, I am just pre-computing when I will use LNR.
Okay,
I am
so you can,
um, basically what I am doing this I am if I am at index 0. So
okay,
I have increased the index of 0 and I have stored the previous vector I have made. Where is that gone? So I have made a 2D vector. So
yeah,
2D vector के 0th index पे I will store this vector.
okay, okay, got it,
Okay, got it?
got it.
हाँ. Then
Means, for example, if I will tell you, if I will ask you that add index number 3, can you guess the
at
index number 3?
0, 1, 2, 3, B.
Okay, so what is the frequency of B at this index?
Frequency of B at this index will be 2 for 0 till this substring, and I will store this substring in my vector.
Okay, so means you are taking a prefix substring, a prefix,
हाँ.
just like a prefix sum logic
हाँ,
that we
yeah,
do in this.
I am implementing a prefix sum logic. A, B, C, D will save the frequency of these characters. Then till this, I will save this frequency of these many characters. Then till this substring,
Okay.
I will store the frequency. So when I will be asked for any query, when will be asked for any query, so basically what I will do, I have till this character, I have till this I have the pre-computation, that is the pre-frequency that we have calculated, and for this
Okay.
index we have. So we will check since that vector is constant of size 26 only. So
Okay.
we will check by running the loop if that particular character is present or not in this substring by subtracting the frequencies. Means
Okay.
from here
Okay.
to here, then here to here I will subtract. If that character is still have a frequency of 1 also, then we will say we will count it in our answer.
So you are saying that you will first take the frequency of all the character till R, then you will subtract the frequency till L minus 1, na? Means that
L,
is which is 1 minus.
yeah, L minus 1 I will subtract.
And then you will check for each and every character, all the 26 characters.
Yeah, since 26 is a constant, so
So means for all that 26 character, what you will check? What you will check for that?
I will check. Let's suppose here, can we take an example?
Yeah, yeah, sure. That is what I'm saying. That can you please write in this thing?
For L equals to 1 and R equals to 5, we take it. So for L
Okay.
equals to 1, what we will be requiring, the vector till here and the vector till here. 0, 1, 2, 3, 4, 5, sorry, here, A. So a vector till here, a frequency vector till here will store a frequency of A as 1, and rest all will be 0.
Okay.
And
Okay.
from here till here, we will have another, let's name it as map 1 till index 0. Till
Okay.
index 0.
Okay.
So
Let's say that your query is from 1 to 4. Take that query.
1 to
L
4
is 1, R is 4.
till index 4 we will take it. So 4,
Okay.
0, 1, 2, 3, 4. So A, B, C, D, D. So A will have a frequency of 1, B will have a frequency of 2, C will have a frequency of uh, C will have a frequency of 1, and D will have a frequency of 1. Now here all our frequency are 0. A, B, C, D till Z all are 0. all are map 0, C0 and D0. So basically what we will do, we will run a loop from 0 till 26, and what we will do, we will subtract the frequency, that is 1 minus 1. Since the frequency is 0, means no character is present for this substring. So we will not count it in our answer. We will check for B.
Okay, I got it. I got it. So can you please
If,
write a pseudocode for it? A
yeah, I
pseudocode
can.
for it?
Yeah, yeah.
Okay, please
So,
go for it. Let's say
so
that the string given to use s and its length is n. They are q queries.
basically this is our vector. This is our vector of
Okay.
frequencies.
You can write it till then. I can just read the comments in our YouTube. You can write there. Yeah. Yeah, exactly, Vivek. We can prefix sum for O1 call if we will pre-compute it. Okay, exactly. Any solution with time complexity lesser than O of n. You can check for it, Priyanshi. But yeah, as he told that we have to first pre-compute that thing. We have to implement a logic of prefix sum. Na? So for that, I think that it will be O of n. You can think of a more efficient solution. Exactly, Sekhar. That is what we can do, and I think that is what he is also implementing. Great. Great, guys. You can also suggest your technique if you guys have something more, means a good implementation, a more effective solution, and you can just comment out. Okay, you can tell me. Fine, Nikhil. You can tell. So first you have iterated from one to n, and then you stored a frequency, right?
Yeah, I will
Okay,
store
okay,
the frequency in the vector. Now I will run the queries for integer I equals to 1, I equals to 0. Let's suppose I have few queries, so I will be given a vector of pair for the queries, or somewhat like so.
but
I
where is that 2D vector? You have also taken a 2D vector in the
uh,
implementation.
yeah, I have taken this 2D
Okay,
vector and I will
okay,
store it.
fine, great, got it.
So just what I will do if my L is so basically you will give me L and R. So I am taking it L and R here. Uh, sir, for queries you will give a vector or what, so that I can write a pseudocode.
No, just take LNR two values.
L
Don't
and
worry
R two.
about that.
Okay.
Yeah.
So basically, if I have L and R, so basically I have just first I have a edge case, that is if L double equals to 0. So I in that edge case I have to check for R, because L minus 1 will be negative, and if L is 0 we are taking a substring from 0 till R. So
Okay.
uh, in this edge case we have to check for R only, and basically for int I equals to 0, I less than 26, I plus plus. Uh, so if uh, basically R रहेगा ना, so basically R vector will be if B of this Rth vector uh, mm, ith position, okay, is greater than 0, then our count will be plus plus. For this case, we have taken a counter as 0, and this is for this case. If
Okay.
L is not 0, then basically what we will do, we will run this loop from 0 to, we will take a value, int value v of r comma r and I minus v of l minus 1 and I, sorry, 0, sorry, I. And we will check if this value is greater than 0. And we will
Okay.
take a max of this value with 0, as it can come negative also.
Okay.
So basically, if it is greater than 0 means this character is present, we will count it, and at last we will return this count.
Okay. Okay. Got it.
So, should I-
Fine. 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 Okay. Yeah. So can you please tell the time complexity and space complexity for this?
Yeah, yeah. I'm just coming on to that. Time space complexity. Since we are using a constant vector this, so we will, as we know, it is not dependent on n, so it will be a constant space. Huh. Now this vector, since it is storing, n vectors, and each vector is of value 26, so we will have a space complexity of uh, n multiplied by 26, after 26 multiplied by n, and time complexity, coming on to time complexity. So in pre-computation, we are running a loop for one time. We are running a loop for one time. So um, and we are pushing every time at the back of the array, which is an O1 operation, but uh, we are just running this loop n times, and so O of n for this time is O of n, big O of n for this, and for this loop, from where we are getting answer, we are running it q times, and for q times, we are running this 26 times. So it will be n plus q into 26, which is, if q is very much less than by n, so it will be O of n. If we talk about complete complexity, it will be 26 into q.
Okay, okay, fine. Got it. Got it, Nikhil. Great. Okay. So
Thank you.
yeah. So now for the next one. Uh, yeah, Amir. Yeah, exactly, Amir. That is what he has also done. That we have to check for distinct characters at 8 index, and then we have to subtract r minus l. Exactly. Good evening. Both are ON. Yeah, Vivek. Both are ON. Both the complexities are ON. Fine. So great, Nikhil. Let's move towards the next problem. Okay. Uh, so the problem is, Nikhil, that I hope that you are in the whiteboard now.
Yeah, yeah.
Okay, let me just explain it. Fine. So the problem is that you are given with a array. Okay. So let's take a array as an example of size n. There will be an array of size n. Is it visible?
Yeah, now it's visible, area of size n.
Yeah, fine. So now what we have to do is that in this array, we have to find the farthest number which is at the right side and which is greater than that number. Maybe it's confusing. Let me just tell you that if this is a 3, so we have to find a number which is less than this 3 and which is right side of that particular index. So for this 3, you can see for this 3, there are two numbers which are on the right and which are less than 3. The first number is 1 and second number is 2. Here you can see. Getting it?
Yes, sir.
Fine. So, but we have to output the farthest number. So you can say that 2 is the farthest number from 3, which is at the right also and which has value less than 3. So for 3, answer will be 2. Is this thing right? Is this thing clear?
Yes, sir.
Okay. Similarly, for 1, you can see for 1 there is no number which is less than that. So for 1, it will be answer will be -1. For 5, there is a number. For 5, there is a number which is 4, which is less than that 5 and which is present at the right side. So for 4, answer will be for 5, answer will be 4. Similarly, for 2, answer will be -1.
Yes, sir.
And similarly, for 4 also,
Answer
answer
will
will be
be
-1.
okay.
Because for 2, there is no number which is less than 2 at the right. And for 4 also, there is no number which is less than 4 at the right.
Yes, sir.
So this is what we have to do.
So should I start?
Yeah, sure.
For this, the name I will tell first the brute force approach. Brute force approach is I will go to every number. Let's suppose I go to 3, and I will start another iteration from 4. So I will check
Okay.
if is 4 less than 3. No,
Okay.
it's 2 less than 3. Yeah. So the first number from backward we will get will we will we will store it in 3. We will loop till 3.
Okay.
For 5, we will loop backward from 4 till 5. If we found the number, we will store it in 5. If we will store it and it in a result vector, and we will return it. So basically, it will take O of n square time, as it is involving two loops. First loop for 3 from 4 till 3, for 1 till 4 till 1 in worst case. If our array looks something like this, 5, 4, 3, 2, 1. So in this case, for 5, we have to run a loop from 1 till 5, as we will get, sorry, uh, 1, 2, 3, 4, 5. For 1, no, 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 no. Just let me think.
Yeah, take
Uh,
your time. Take your time.
for 3, the
If I
first,
will just tell you the answer, so you have to also return a, you have to just return a array as the answer. The
hmm.
array means the answer array.
So,
Means for each number you have to output its corresponding number. Basically the index of that corresponding number. Because for you can see that for this 3, that corresponding number was 2.
yeah.
And index for 2 was 3. So this is
So,
how you have to output a corresponding index of that number which has the value less, which is present at the farthest from right. Getting it?
So yeah. So basically, I am running a loop from 0 to n. Then I'll taking a value as -1. Uh, then I am running a loop from n minus 1 till I am running a loop till j equals to I, and minus minus, not till I, it till this. So basically,
Okay.
what will happen if I will get a if I will get an array of j which is less than, I have to check for strictly less than. So
Yeah,
you
yeah,
have
yeah, smaller. Yeah. Strictly less than.
ARR of j is less than ARR of I. Yeah. So basically, what I will do, I have found my number and I will break it. So first value I will store, that is ARR of j, and I will break it from this loop. Um Break it from this loop, and I will store result. If I have this result vector, I will push back in this vector my value. If I would have not found my uh, value, it is initialized to -1. So this is a brute force approach, since it is involving two loops. We can see. So
Yeah, yeah.
it will take a time complexity of O of n square, and if we have been given with 10 to the power 5, then this is not possible to implement with this approach, or it will give a TLE.
Okay.
We have to find. So should I tell another approach?
Yeah. If you have a more efficient approach, you can think of it. You can just tell me.
Yeah, sir. Can I take 2 to 3 minutes? Hello.
Yeah.
So can I
Take
take?
your time. Yeah, sure. Take your time.
Uh, I am just getting the clue that we have to use a stack which is monotonic in nature. Uh, but I'm not getting the hint. It's just a question similar to next smaller element and next greater element.
Yeah, but it is not next. It is the
Uh,
farthest one.
it's just a modified version of it. Uh, Basically, we will store a 4 in this file.
Yeah, Amir, you are right. Okay. You can just implement that thing. You can dry run that thing which you are thinking. Maybe it's right. You can dry run that thing, or just if, as you said that you are thinking about the stack that is used to found the next smaller element, but it is a modified version. So can you just change any approach? There's another method that is, so you can just think of it. You can try to approach.
So, not, can you please pardon?
Yeah, I'm saying that you are saying that to find the next smaller element, you have to apply stack.
Star. Yeah, monotonic
Yeah,
star.
but here it is the farthest, means not the next smaller, last smaller, basically the farthest smaller number. Maybe stack can be not used, maybe some other data structure can be used, some other technique can be used.
Uh,
You can take pen paper, you can think of it, you can just,
Maybe Q.
yeah, you can try, you can implement.
It's a first in, first out. Yeah, so basically, what I am getting a hint is that we can use a queue data structure as queue follow the first in first out order. So what we will do, when I will come to 4, I will store a 4 uh,
Okay.
in the queue. As the queue is empty, so I will give the answer of 4 as -1. Then I will go to 2. Uh, then I will go to 2. Uh, then I will go to 2 and I will store a 2 in the queue. Uh, one is decreasing.
Okay, no problem, Nikhil. No problem, Nikhil. That was a great one that you have just figured out that how we will implement it in a brute force manner. Okay, and yeah, this is basically a problem where we will combine the prefix. You have you thought about the prefix thing? How we find and pre-compute using prefix? But here, because we have to find the from back, so we have to find the minimum suffix array. Just a hint from my side.
Minimum
Can you just find
suffix.
the minimum suffix array?
Uh, Minimum suffix array.
Yeah.
Sir, I have not heard about this term minimum
Yeah.
suffix array. So,
Yeah, that is not a very big concept. It is like that we have to iterate from back, okay, means suffix of this array, okay, and then you have to store the minimum element till that. For example, if I just write it here, so you can see that till this index, till the last index, minimum number is 4. Got it? Okay.
yeah. So,
Now
yeah,
till,
yeah, I've got it, got it, I've got it.
yeah, yeah. This
We
is
will store 2, then we will store a 1, then we will store a 2. Sorry, a 1 and then a 1. Okay.
getting it.
Yeah, yeah.
Yeah. So this will be the minimum suffix array.
Yes.
Yeah. So now, just a little bit that how we can solve it. Just a little bit logic.
Basically,
You can say that this suffix
Yeah.
minimum array
So,
will be in sorted order.
um,
This will be always sorted order.
yes, I got it. I got it. We can from this from one of the this approach. I am getting another approach that I used it to find using stack only. Matlab,
Okay.
I have implemented this thing, the concept you are telling, using stack only. So what I do is when I get a 4, uh, basically what I do, I maintain a monotonically decreasing array,
Okay.
monotonically decreasing stack. So what is there? I will store a 4, then I will get a 2. So I know that uh, 2 is the smallest
Okay.
till their index. So the element which would be greater than 2 would have an answer as 2.
Fine. Great.
So what I will do, uh, um, no, sir. I just it's a wrong approach. I have thought of some cases.
Yeah, no problem, no problem. So let me just explain that thing. Okay. You are very close. That means that you are very close to the solution. So it's great.
So
Uh,
basically,
so
what I am
so
thinking, uh,
yeah.
if I am at a particular index, so I will jump to that index and I will take that index. Iska minimum, I will jump to another index. So, so the last I could jump is the answer. I have been thinking of this approach. Let take one. So one say I can jump to. Uh, uh, we have to find ना कि वन का smallest कौन सा हो सकता है अगला. तो वन से uh, as this is only the smallest till now, तो इसके लिए तो कुछ not possible. But 5 के लिए we can jump. We will jump to 2, and for 2 we will jump to 4. तो 5 we will get a 4. अगर
Okay.
4 का कोई होता तो उससे smallest आ जाता.
Okay.
So I have been thinking of this approach.
Yeah. So now let me just share the screen. You can just unshare it. Yeah. Great. Okay. So here what we can do is that this is the array now, which is the basically suffix minimum array. Fine. So now from here, what we can do is, Nikhil, that we can apply binary search here. And using that binary search technique, what we can find that after this 5, because we have to take the sub array which is after that index. So for example, we are searching for this 3. We are searching for this 3. So for this 3, we will take a sub array after this index. Means this will be the sub array which we will take. Okay. And in this particular sub array, we will
Upper bound.
apply binary search. So let me just write a pseudo code for it. So it will be something like that. Okay, that int, is it visible? It is visible now. Fine. So it is int. Okay, and which will be the basically the mid element of this particular array. That is clear. The mid element of the sub array given to us, Nikhil.
So yeah, it's clear.
Okay. So now what we will do that if that mid element, okay, and let's say the current element is arri. Okay. So if that mid element which we have is basically greater than the current element. In that case, we will update our value to m minus 1. Means, for example, if it is r and our current element is 4, so means our smallest number is basically before 4. So we will update the value of r to m minus 1. And if it is less than ARRI, then obviously we want that thing. So we will update it in another way. Okay.
Yes,
So basically we have to apply binary search here. Just like what we do in, just like what we do in
that's
that
okay.
case now when we use upper bound and lower bounds. Getting it? Fine?
Yes, sir.
Yeah. So is this thing clear now?
Yes, sir.
Fine. Okay. So Nikhil, your approach. If I will talk about this approach, this will take just the time complexity of O of n only, uh, because that binary search will take log n, and this suffix array will take n. So total it will be O of n.
Oh, okay. Yeah.
Okay, fine. So great, great. So okay, Nikhil. So it was a great experience. Means that the first problem, which was the missing number, you have just got it very well. That particular problem. Okay. Uh, and yeah, second, you are just thinking of the right thing that we have to first find a minimum suffix array. Then we have to modify it. Great. Yeah. So that was the great approach which we have taught. Okay, and in which we will use XOR. Okay, and the second problem, which was queries on string, in that also you have just got that prefix some approach that we have to first find it, and then we have to first pre-compute it. So that was a very great thing that we have taught. So, and if we talk about a third problem, and you have got that brute force approach very well, and yeah, you are very close to the exact solution. Means after that suffix sum, you are just saying that we can use q, or we can just, but you are not just able to explain that thing in a great way. So yeah, so you are also very close to the next third problems. Overall, it was a great experience, Nikhil. And if I just the feedback session, so how you are thinking of the problems, how you are approaching. First, you have approached the brute force approach, then you have approached the efficient approach. That was really great. Just a feedback for you. Just a feedback for you, Nikhil. That when we are when you are thinking of a solution in an interview, then you have to also tell it to the interviewer in just after 5 seconds or 10 seconds. For example, when you have taken break, when you are thinking of the for the third question, then you have just you are just quiet for some minutes, and that time maybe there was a connection break between the interviewer and the okay, yeah,
Yes, sir.
attender. So that time you just try to coordinate, just try to interact with the interviewer that yeah sir, I am thinking like this, I'm thinking like this. That is the thing. Otherwise, when you are writing the code, you are interacting, it was great. When you are thinking of that, then you are interacting, it was great. Okay, but
Sir.
don't take a good amount of time break between the communication with the interviewer. Okay,
Yes, sir.
great. So great, Nikhil. So thank you for joining. It was a great experience for me, and I hope that you have also learned new things. Great,
Yeah.
Nikhil. Thanks.
Thank you, sir. It was great. Uh,
Yeah, thank you. And also, guys, if you also want to just if you also want to be the part of these webinars, these mock live interviews, so the link is given in description. You can just fill that form, and you can also be the part of this live mock interview on this Geeks for Geeks YouTube channel, and you will be get a chance to take an interview with me and other mentors like in this live Geeks for Geeks channel. Okay, guys. So thank you. I hope that you all have got the you have all have learned this from this session, and it is a good session for you guys. Okay. Thank you, Nikhil. Thank you for joining. Thank you.
Thank you, sir.
Great.